Oh, that's better. I think I was on mute. Okay, can everybody hear what I'm saying? And is it okay for me to proceed?
Yes.
Right, I'm just doing a few shares. Right, okay. Okay, let's make a start. So can everybody hear me okay? I'm just conscious I was playing, I upgraded my PC earlier on today and I was a bit panicky, nothing would work, but can everybody hear me okay? Yep.
Yes, Paul, please proceed.
Perfect. Okay, let's get cracking. So apologies for the slight delay. I wasn't 100% sure the protocol to get started. So welcome to this session. I think we've got from a very, very chilly United Kingdom at the moment. Anyway, so it's a lot warmer in other parts of the world. Wanted to run through sort of like big data, artificial intelligence, Internet of Things, and cyber security and risk. I'm going to try and use this as I think I've got an hour session, so hopefully we will have some time for some questions afterwards. But I'm going to focus very much on pragmatic hints and tips. So just scrolling down the screen now. So just before I dive into the detail, a little bit about myself, just to sort of like make you answer the question, who's this strange man talking to me regarding cybersecurity? So my background is I've been primarily working in change management over nearly 35 years now, experience of implementing change across a number of industries. Obviously, a key part of that has been around technology and cyber risk and new emerging technologies. I also author and speak on a variety of different subjects, including obviously technology areas. I've published a number of books. I'm a director of a number of charitable organisations, primarily based in the UK. Just moving down to the bottom now, I work for the Open University in the UK, teaching technology management. So if we just dive into the details, so I think the first thing is probably I've got six areas mainly to cover actually. The first 3 or 4 are more around background setting. So I think the first item, I just want to run through a few key definitions at the beginning. Again, some of these are quite obvious, but I think it's worthwhile just double checking we agree, or for the purpose of this presentation, what the definitions are. The next item I want to talk about is sort of like the items 2 and 3 linked together, is how technology and the world is all linked together, and how important it is to manage cyber security and cybercrime holistically. Then on number 4, I'll talk about some of the high-level threats, in particular around sort of cloud, Internet of Things, etc., impacts there. And then most of the presentation will be number 5, which is a number of hints and tips and best practices and worst practices, I guess, around how to improve cybersecurity. And then there's a final item down the bottom, which I will touch on at the very, very end, is how technology, particularly machine learning techniques, are now being used to combat cybercrime. So if we just dive into a few definitions first, the first one is just a general definition of what artificial intelligence is. Again, you just want to make sure we have a clear understanding, because obviously I don't know everybody's background. So effectively, AI, or artificial intelligence, is the ability to develop computer systems that try and copy the human intelligence. And it contains a number of sub-elements such as the Internet of Things, big data, natural language and processing, and many other areas around machine learning. It's actually quite an exciting and vast area. The next area relates to definition of Internet of Things. Again, sometimes this is actually called the Internet of Everything. Basically allows any physical object or a thing to be added to the internet. Traditionally, there were devices on the internet such as personal computers, tablets, iPhones, etc. But now, in theory, you can add anything from photocopiers, security cameras, door swipe cards. So anything can be added to the internet, which obviously it creates lots and lots of benefits, but opens up thousands and ones of security holes. Big data is another phrase that's bounced around a lot and often used incorrectly. But ultimately, it is basically three areas. One is having a large amount of data. The second area is the large amount of data is constantly changing. And lastly, it's actually this data is held across various different mediums, such as databases, videos, social media, postings, etc. Natural language in processing, which again I do talk about a little bit later on, is its ability to effectively program in computers that can understand human language as an input, so it can be input into systems. So this is ability to understand properly speak recognition, or text messages or WhatsApp posts and stuff like that to process that. And also the second part is the ability to present natural products coming out. I mean, a prime example is translations. So Google, will input using an NLP a French phrase, and then we'll translate it to German. Machine learning, again, which is another very exciting area of new technology, is very much along the lines of allowing computers to learn and improve without being specifically programmed. And there's various ways you can have supervised machine learning, where you know what the goal is and you try and learn from that, or unsupervised, where you try and analyze lots of data. But again, it's a very, very exciting area of technology. And last but not least is cloud computing. Again, there seems to be the silver bullet for these things, but at a very, very simple level is using a network of remote servers, typically outside your organization, to host and manage your data, as opposed to having it on a very complex in-house data center. So that's a few key definitions. If we just dive into just sort of like these two next items, 2 and 3. I don't think you see my mouse. 2 and 3 are quite linked together. I think the point to mention here, I'm trying to stress here, is when I come to the hints and tips, is that technology and the world is generally linked together. So where you can have a number of inputs into your systems, for example, you can have your old data feeds, you can have inputs from Internet of Things objects such as sensors, video cameras, and stuff like that. You can have input from natural language in processing. You can have smart devices, the web, and the fact clients. So you've got a very complex set of inputs. And this will then be processed by a number of different methods. You can have your traditional software. For those of a certain age will remember areas such as COBOL programming and other database technologies. Then you can have artificial intelligence, which we discussed earlier. You can have machine learning, business processes. And people still hard there. And despite what everybody does, there's thousands of spreadsheets all together in a horrible spaghetti of mess. And last but not least, there on the inputs, you can offset the outputs. Again, it's very similar to the inputs, but reverse, you have it all out. So if you can imagine here, you're going to have a very, very complex set of inputs and outputs all linked together. And then while people tend to think about Internet of Things or spreadsheets or smart devices as separate items, if you can imagine, they're all meshed together. So this sort of like linked up together is further enhanced by, a lot of this stuff uses big data. It's based on the cloud, multiple cloud providers dotted around the world. There could be different suppliers, there could be different locations, there could be different time zones, and there could be different teams or different departments. So the end result here is this. Everything, when you think about cybersecurity, it's obviously important to think, particularly for this definition of this presentation, is the Internet of Things, big data, and cloud. You need to think of cybersecurity as everything linked together across, all the parts of your technology and business infrastructure. So hopefully that demonstrates a few key definitions at the top. We've talked about how everything's linked together, but what is exactly cybercrime and cybersecurity? Again, it may be obvious, but I thought it would be worthwhile touching on it. Basis, just to make sure we have a clear understanding. So cybercrime is effectively using a computer to commit a crime. Again, I mean, it's as simple as that, really. Then that could cause disruption to the computer system by making it unavailable. It could be theft of data or customer details or people's details, personal details. It could be used to damage the computer. People go in there and randomly delete files just for the use of it, or it's using the computer for unauthorized use. For example, taking over an Internet of Things device and using it for some sort of criminal activity. And therefore, logically, what is cybersecurity? Cybersecurity is putting the technology, controls, and processes in place to stop cybercrime happening. So basically, this is getting more important these days because all organisations rely heavily on technology. For example, I'm based in the UK. Previously, last year, particularly in the year before, that worked mainly in financial services. They are completely relying on technology. A technology outage in a financial firm will probably mean they will stop for business completely within several hours. And if there are major technology issues, there are a number of problems. For example, you can have operational aspects. You imagine the grief. The challenge is if it's not a bit. If, for example, you cannot pay for invoices online or banks can't do bank transfers, absolute disaster. Customer impacts. Imagine if a client can't go online and order at Amazon or look at his Facebook postings. Supplier impacts. Actually, I worked at a place where before there was some sort of breach on I think it was a cloud computing vendor had a breach, and what they ended up doing, there was some sort of virus or some sort of malware that was introduced just through a hole in the cloud computing security, which then impacted every single one of their customers and clients. Well, safely say that cloud provider wasn't very popular and they lost a lot of clients. There could be legal impacts, for example, if you're deemed to have made an error or for example, you had a machine learning algorithm that didn't work properly or was faulty, you could actually end up upsetting a client or making something wrong with a client, and you could end up with a legal case. Regulatory impacts, again, primarily I can speak from financial services in the UK and Europe and the US and well, actually the rest of the world. Financial services laws are incredibly strict. So if you you can actually be severely fined, and including severe restrictions such as imprisonment, is if you don't have sufficient controls around your cyber security, in particular around newer technologies. There'll always be a cost. Yes, these things is, apart from the fact that, if you lose your systems for a week or so, then you could actually, it will cost money to replace them. Another one is reputation. Actually, as it happens, one of the clients I work for, their accountant ran everything on a nice cloud site, but they got the cloud sites now crashed because of a denial of service attack, and they've not been able to do any accounting business for 2.5 weeks. And I know, for example, a number of clients I spoke to who use them, their reputation is absolutely destroyed, and they're going to be losing lots of clients. Veiled threats, which is the ability to say if you don't do something, a bit like a ransomware type thing, you can do something, don't do it. And extortion, which is effectively saying, if you again, it's like those two are very similar. Like extortion, you say if you don't do something, we don't give us lots of money, we're not going to give you your systems back or do something similar along those lines. And remember again, so basically, if firms do not look after their cyber security and their cyber crime, and in particular, with the newer technologies such as cloud computing, cyber, etc., firms do not recover. I mentioned that example with the accounting firm I mentioned earlier. And in fact, some firms, again, I'm not aware of any particular firms, but they have a complete failure. So that's an absolute disaster. If you look down the bottom left-hand corner here, there's a link here to Kaspersky, which as you all probably know is a virus protection software. They've got that link there has actually got a long list of failures and errors that have happened around the world, and it's actually quite interesting and terrifying to read at the same time. But the key point is that organizations need to protect their technology infrastructures, regardless of whether it's based on cloud computing or Internet of Things or artificial intelligence. Regardless of the approach, it needs to be protected. So what are the type of threats? Again, just to provide a little bit more background, and I've listed, I think, 12 or 13 here, and these are I just did a simple Google check on these, so I'm sure there's hundreds more out there. So the first one is backdoors. Again, for those of a certain age, you may remember an American film from, I think it's 1983, called War Games, where a hacker used a backdoor to access, which is an old password or a special piece of software to access the American nuclear control system, and effectively bypassed all security. Unfortunately, those backdoors still exist. There's bots, which is short for robots, which is where a piece of software will take over a computer, obviously in a bad way, to do some other attacks. For example, a hacker may or an organization who wants to target a government organization, may take over a large number of Internet of Things devices, maybe even PCs and tablets, remotely, and control them through a bot to sort of like attack the computer they want to attack. Data leakage, again, that's the same data. The data's been leaked out, and that can be anything from somebody leaving a floppy disk on the London Undertransport, or somebody hacking into a cloud server to try and access the data and what have you. And for example, you may get a foreign government or a competitive organization trying to access data on their organization. Denial of service seems to be a very popular one in a very bad way, and this is effectively just swamping a website with repeated requests just to clog it up and make it crash. Form jacking, again, which is obviously a play on words around hijacking, where you insert a malicious piece of code such as cross-site scripting into a website or a form to either take over the form or to capture data. And prime examples around things like personal data or payment details. Identity theft, which is where you obtain enough details from somebody to take over their name or their personal information, and you try and get credit cards, loans, and accesses. And this actually happened to my father, a couple of years ago, where somebody created a mobile phone in his own name and started charging him for the use of it. Insiders is where you have somebody inside an organization who is part of an inside job, I think they call it in America, who's part of the criminal activity. And again, it could be a current employee, a former employee, it could either be a supplier, it could be a customer, or it could be anyone. Again, it's very hard to do. Malware is intrusive software that is designed to effectively, it stands for malicious software, which is software that is designed to damage computers and other systems. You know, for example, it could be a virus or a worm or a Trojan horse, spyware, ransomware. Normally, typically, it's downloaded by accident. Again, you might accidentally click on a link and it downloads it. Again, with the world of Internet of Things and cloud computing and big data, it becomes much more easier to be infected by this because, you know, the malware could be installed in an Internet of Things device. It could also be installed on your cloud service provider. So again, it's really challenging. Man in the middle, or a person in the middle, to give it its proper name, is where somebody protects himself in a conversation between the user and an application. Again, in the old days, it used to be somebody used to try and insert traffic as it was going between one server and another server. But I've seen examples, in particular, around sort of like where you get activists will try and hijack Internet of Things devices. For example, somebody who's using an Internet of Things device to look after security on a power site, and they will try and hijack or get themselves in the middle of that to try and interact all any data. And then the next one around password cracks, which again is exactly what it says. It's trying to hack passwords using software. Phishing is using methods such as emails to try and obtain personal or corporate information. So phishing is needed really to do insider, and it's just trying to obtain passwords. And it's amazing how clever these people are to get them out. And the last one here is SQL injection attacks, where somebody inserts, often using some sort of like input form, a SQL statement that will actually run and provide data or accesses, or just called general chaos, when they submit the form. So a number of threats here. Some of these are sort of standard threats that input that hurts everybody, but some of them are actually very specific to cloud and Internet of Things, which I'll come to in a sec. The motivations for this, you do wonder why some people want to do this. You may have country to country. For those who may be reading the news, there's a lot of heightened tension between the Ukraine and Russia and the European Union, UK and America around Ukraine. One of the things that most of these countries are worried about is some sort of cyber attack if hostilities break out. So, you know, you would probably find both sides will look to attack the other side by attacking their cyber networks. Again, curiosity is a strange one. I must admit, when I was quite, you can probably tell by my photo I'm quite old, but when I was younger, a lot of people used to hack into systems just to see they could do it, to see how they could do it. They'll hack into an IBM mainframe or a Unisys system, see whether they can do it. There's also financial gain. There's operational espionage, which is also organizational espionage, which is stealing secrets. There's political. You know, you could be, for example, you could be a big fan of one political party, and you might want to impact another political party by stealing their secrets. A vandal, where you just log in and you want to cause total chaos because you're not a nice person, plus many others. And these attacks could be direct or indirect. Okay, so we've covered we've covered the definitions, we've covered the technology, what is cybersecurity and cybercrime. We've done a very high level skim, but I think the next 20 odd minutes, I think most of the presentation, I'll probably talk about some hints and tips about, you know, in particular around cloud, big data and Internet of Things. I will veil this is not a fantastic way of, sorry, not a complete 100% list, but it's like most things, you learn from mistakes. And the first point to mention is, while some of these hints and tips are quite general on cybersecurity, whether, but I think the key point to mention is that good cybersecurity is required across generally, and a lot of the key principles will still impact for cloud, big data, Internet of Things, machine learning. So there's a massive overlap. So the first one is be paranoid. So I think the key point there is, as I mentioned earlier, you've seen that technology infrastructures are very complex with lots of people, customers, suppliers, business processes, locations. Therefore, you need to be paranoid that somebody's going to try and hack into you or cause some sort of cyber crime, whether it's attacking your cloud infrastructure, trying to break into or steal your Internet of Things devices, etc. So you've got to also remember, despite the great work that's done by the cybersecurity industry, cyber criminals always appear to be ahead of the industry. You think you've solved one problem, and before you know it, they've created another problem. So therefore, expect problems and prepare for them. So there's no harm in double checking everything. So if in doubt, be paranoid. And a number of general tips. The first one is, again, it's a sort of a standard thing, is to design security into your technology and business processes, and not to include sort of cyber security as an afterthought. And this is particularly true for some of the newer technologies, such as Internet of Things, cloud, big data, machine learning, and in fact, all aspects of AI. Is that these are very complex technologies. The integration between them is very, very challenging. So therefore, it's important when you do the design, you do the design up front, especially if you need to install encryption and separation of data and password controls. Is as soon as you start designing the system, include it at the beginning. Don't think 3 weeks before I go live and think, right, okay, let's work out how we're going to encrypt everything. Important also, as well as covering every area such as human aspects, physical aspects, and networking. I'll skip these items here because there's a slide on these later on. And another area is important is customers and suppliers. There's a pretty good chance if you use a cloud provider and big data provider, you can get that data from a supplier. And there's a pretty good chance if you've got Internet of Things devices, you will need a supplier to supply those, and no doubt also need probably have customers who use them. So it's important that when you design this, you ensure that the customers and suppliers are involved in this design decision. And it's not uncommon for certain large complex infrastructures to employ specialists to help you with this. For example, many years ago, I worked for a large international financial services firm. And in the country they were situated, they were deemed critical infrastructure, which basically meant the national government would send in teams of people to try and crack into their security. So what they would actually do is send people undercover at night, literally, it was all quite cloak and dagger, to try and hack into the systems, trying to physically break into the locations by covering fences, trying to hack into suppliers, trying to take over customer computers. I think even one point they even stole a security camera, like an Internet of Things device, sold it, actually unscrewed it, removed it, and sent it back to the client and said it was so easy to remove the security camera. The security camera was next to useless. So again, these specialists certainly know what they're doing. Also, a general thing, again, it's a general thing, but obviously important for Internet Things, cloud, big data, what have you, is test security when deploying or upgrading technology. When you install new technology, you will always do some sort of functional test or stress test or volume test and backup tests. Again, which is fine, which is perfect, but also ensure that when you do it, you test for security as well, which basically means testing, can somebody hack into the Internet of Things device? Is the encryption between the Internet of Things device correct? Is there segregation on cloud data? Is cloud data being encrypted, etc.? Again, make sure you look after the aspects of customers, suppliers, and again, employ specialists if required. And one other area here, just before going to the next slide, is review legislation. Depending where you work, and particularly if you're a multinational company across many jurisdictions, cyber and data laws constantly change, or they get more complex, to be more precise. So therefore, actually, by not reviewing legislation and keeping yourself up to date, you could actually be breaking the law. And for example, one of the biggest challenges I had being in the UK, for those who remember, UK made an absolute disaster decision called Brexit to leave the European Union a couple of years ago, which basically meant all the data laws changed overnight, and there was a massive amount of work to try and get that done. And again, remember customers and suppliers, they're often forgotten about. And a few other points: keep reviewing activity. I know it's a little bit big brother and people don't like being reviewed, but run checks. There's lots of tools you can get. You can employ specialist firms again. Does anything look strange? Are there any strange behaviors? Are you getting access from odd locations? For example, if you've got an Internet of Things device or a cloud provider and their behaviors just look out the normal, then it could be something could be wrong. It could, again, just be something normal. But again, it comes back to the point before, be paranoid. And again, suppliers and customers, that's going to be a common theme, and employ specialists who can do this stuff really well. The point here is about sufficient oversight and governance. Again, this is more of a general point of cybersecurity, but again, does impact Internet of Things and big data, etc. Is that make sure you've got sufficient oversight and governance in place. This basically means is that, as it comes back to the point I mentioned before, things will go wrong. Whether these things are real issues or something that just looks odd and it was a non-issue. So therefore, you need processes in place that if there look like there's been a security breach, for example, you're worried that an Internet of Device sensor has been compromised or been tampered with or doesn't seem to be operating properly and you don't know why, then you need an ability to raise that issue immediately so it can be escalated to management if required and managed and then brought to an end. Nothing frustrates customers and clients anymore is that they know there's been a security breach or a data loss and they find out about 3 weeks later. And last but not least, under this section anyway, relates to backup plans. As I mentioned before, this no matter how hard you work and how well you prepare, there will always be problems. And it could, as I mentioned earlier before, it could be disruption, theft, damage, unauthorized access. So therefore, have fallback plans. What will you do if you think there's a data loss? What will you do if you think there's some sort of damage to your systems? What will you do if there's an attack on an internet thing of device has been compromised? It's inserted a virus that's actually causing all sorts of problems with your websites. What do you want to do? You need to think about all these scenarios and plan for them. And then come up with, as I said before, come up with plans for them, but constantly test and retest them, make sure they're okay. In the same way you would test any other contingency or promotion in the organization, you need to test these thoroughly. And last but not least, the most important thing I reckon actually is communication plans. Again, there were a number of large data breaches in the UK last year. One was a social media site and the other one was a mobile phone firm where credit card details and payment details got stolen, but they didn't actually tell the customer to about 3 months afterwards that they're being stolen. Which went down very, very badly, to be fair. And both those firms got very lots of bad publicity. I think if you have a problem, you need to know if you've got certain scenarios what the comms is to the external world. So, for example, if you think you've got a data breach because your cloud provider's made a mistake, then you probably want to have a backup plan in place or a comms plan in place that you will tell your clients straight away. Literally go tell your clients, log on, change your passwords, and do it immediately. So basically, they won't be happy because your data has been perceived to be stolen, but they're going to be even more unhappy if they don't find out for weeks later. So we've sort of done some general paranoid, we've done some general things, but the human aspect is also another one, regardless of whether it's cloud or just general cybersecurity. So the first one is to have clear procedures and policies in place for all your staff. You need to ensure what are the rules regarding cybersecurity, what can they do, what can't they do, and make sure they're aware of these, because some of these can be quite tough rules. And you don't want an excuse where something goes wrong, like somebody's forgot to run a security patch, or they haven't deployed a change request properly around security and it's caused issues. You want no excuses. You want to make sure that staff know what they can and what they should and they should not be doing. Make sure there's ongoing training at a general level around security. I think at the top level is to ensure that individuals really understand what cyber risks are around cloud and big data, Internet of Things. Can somebody? I think there's a little bit of background noise. I don't know if anybody could just turn off their mic, if that's okay. Okay, it's got, yeah, sorry. Sometimes this can get a weird echo. So ongoing training. So I think the issue there is just ensuring people really understand what the risks are to cyber is, particularly around big data, cloud, Internet of Things. So a lot of organisations I've worked with, we have training sessions, normally online sessions really, with some interactive quiz at the end. where they will go through various scenarios to make sure they understand cyber and the implications. So again, there's no excuses, so if people don't know, they should know. And the other way also is attestations, which is a very posh word for saying sign off, that people sign off that they've done the training and they understand it. It's also worthwhile including disciplinary measures in contracts if required. For example, if somebody constantly breaks cyber policies and, for example, is exposing the company to data leakages because they're not ensuring the cloud is tied down as much as it should, you don't really want this happening. So you might want to include disciplinary if required. Again, often mentioned before is to monitor staff usage. Again, it's a little bit big brother, and some people find nervous. But the way I would spin it is to say they're there, this monitor there is to protect you. And they make sure any strange behaviours are investigated. I mean, they could just be normal, but they could be something a bit more sinister. Either the staff member could be up to something unusual, or the staff members' PC could have been compromised and been used incorrectly. And finally, as you guys all know, cyber-security is incredibly complicated. You're all very bright guys, and you probably all know bright people I mean. And in time you overlay the complexity of the Internet of Things, cloud, big data, machine learning, NLP, logical regression, sector vector analysis, and all stuff like that, you've got a very, very, very complex set of stuff that needs to be looked after. So it's very important that organisations have suitably skilled staff who can actually manage the aspects of cybersecurity as well. Right, we'll talk about suppliers and customers next. Again, I've sort of touched on this a few times, so I will probably skim over a little bit of this. I don't want to bore you with duplication. But the first thing with suppliers, the first thing is to choose your supplier with care. If you are using a cloud provider, there's almost a pretty good chance you're going to use a supplier. If you're using the Internet of Things, no doubt where you're going to buy the interaction with the Internet of Thing object, or even the thing itself, will be provided by an external organization. And if you're using big data, machine learning techniques, the algorithms and the data and the systems that are going to host it will be suppliers. So therefore, this is a major cyber risk for these areas. So it's most important that you choose your supplier with care. And there's 4 areas I tend to look at. The first one is the functional fit. And this is very much along the lines of, does the supplier actually provide the functionality you need? So, for example, if it's a cloud provider you want to provide, can they provide all the data requirements? Can they host the applications? Again, very important that they can do what you need them to do. It may be a case if they can't do it, then you may not be able to take that supplier. The second area is around legal fit. Make sure there's suitable legal contracts in place to manage that supplier. That can range from anything from delivery of the services all the way down to ensuring the specific clauses around cybersecurity. You may say, for example, we are very unhappy when we reviewed your contracts that you're not doing enough around encrypting data in the cloud. Therefore, we want you to change your contracts and your services to do it. They might come back and say, no, not interested. And then therefore you've got to make a decision whether you proceed or not. The third bullet there relates to implementation fit. Again, this is very much around it. How quickly can they install your service? So you might have a supplier who's very good at functionality. They've defined that you're very happy with all the legal terms they've got. They're going to take 6 months to install it. And you might think, well, no, that's not good enough. We want it in 6 weeks. So you may have to pass on it. And the last one is cultural fit, which is a bit of a sort of a wishy-washy management phrase. But ultimately, that means how well can you work with that supplier? Again, it's very important at a general level. If you're working day to day on an operational aspect, you want to work together, but you want to be able to work with this organization to understand that they're going to be generally open and honest with you if they have any cyber issues. For example, if they realize that one of their other clients had a cloud data leakage, therefore you will want them to tell you about this straight away, even if there's no impact, as opposed to you hearing from it from in the local press. Again, I sort of like slightly veered onto this, but earlier on, are you happy with their cybersecurity? So again, for example, if you're using this provider to provide a cloud service or big data inputs or Internet of Things, as I mentioned earlier, or running machine learning algorithms, you want to make sure that you're happy with their cybersecurity arrangements, such as policies, training, selecting their staff, oversight, etc. And if you're not happy with them, you can either ask them to change. If they change, and then say, well, thank you very much, nice people. If they don't change, then you can actually say, well, either we're going to risk i.e. we go with them but understanding there's going to be issues, or we do not use a supplier. Legal requirements, again, you want to make sure, as I mentioned, you sort of touched on it up here, you want to make sure contracts have legal requirements in. And another thing is to do is to run a number of audits with the suppliers on a regular basis. I mean, I set up a process at a previous place. It wasn't on cybersecurity. It was actually it was on data protection, but I suppose it's slightly different. Is that we would reserve the right to turn up anytime we wanted, albeit only once every 6 months, to review their supplier arrangements. So every so often we'd just turn up in the client's office, knock on the front door, turn up in the supplier's office, knock on the front door and say, we want to come in and we want to review all your arrangements around data security. And again, that was a very sort of like a hidden audit, because we will give the client we'll give the supplier no indication of what's happening. And the other area which is very, very worrying at the moment is, and I would suggest really, if you're thinking about this seriously, is to focus on this, is the suppliers. Even though you might hire a supplier to do something, that supplier will no doubt use other suppliers to provide your service. For example, I worked, again, a large large American, it was actually, investment manager, financial services manager, and they employed a software as a service to do their online trading. But the provider of the software as a service provider then used multiple cloud providers and actually some machine learning techniques actually to provide the service, but they were provided by another client. So effectively you had a supplier. So when we were doing all the choose your care and cyber security and legal requirements, we had to audit the suppliers. So from their ability to make sure they were looking after the cloud and all the big data inputs and the machine learning algorithms. So suddenly this became incredibly complicated just because the way the supplier had set themselves up. Customers, again, you need to be customer aware. They could have, if you have a customer who is using a device, for example, let's say even like an iPhone or an Android device, or if you've got a supplier or a customer who deploys some of your technology on their site, such as a remote scanner of some sort, you need to make sure that they're not opening you up to risks around big data, cloud, Internet of Things. But unfortunately, it's harder to do with a customer because they're paying you as opposed to you paying the supplier. So it's important, you probably just need to be more tactful with them than anything else. Again, you might want to include certain cyber clauses in the contracts, again, just to protect yourself, to say you expect the customer to deploy a certain amount of duty and reasonable behavior to ensure that if they're using Internet of Things devices, they're not actually causing, they keep it up to date and what have you and stuff like that. And maybe you have clauses in there, if it all falls to pieces, you can actually terminate the client arrangement. And again, in a similar way, I've actually got the word suppliers there, it should be customers, but in a similar way, you might want to audit customers as well. So the physical side of access. So again, probably this is quite important for Internet of Things, actually, to be honest with you. So at a general level, any building access, you want some sort of controls around there. So you want business and technology areas to have some sort of like constraints around that, access that. You don't want people walking into data centers. You don't want people walking into restricted areas, willy-nilly having a look around and picking data up. That can obviously be done by a number of areas. You can have access controls, such as access cards, swipe cards. You can do video recordings. You can even use biotech. I've done biotech where you put your thumb on a little reader and he looks into your eye. It determines I am me and lets me in. But the other thing is around also quite interesting one is around a clean desk policy, which is basically each night make sure your desk is empty and everything's locked away. I did work at an oil firm actually many years ago, and they did an audit one evening of people's desks and what was out. And the amount of stuff they found was actually, it's quite frightening really. In fact, they actually found a list of sort of like critical IP addresses for scanners they had on oil rigs and stuff like that. They also had lists of key architectural diagrams and stuff that, if it fallen into the wrong hands, somebody could have caused all sorts of havoc with Internet of Things devices as well as clouds computing. So again, that's a good idea. Again, Internet of Devices are, this is where it gets quite challenging for them actually. First of all, you need to ensure they are tamper-proof, which is basically means you don't want somebody coming in, smashing it up, altering it, replacing it with something else. So you need to make sure if it's where it is, in some sort of physical casing, that's actually quite hard to break into. And it is broken into, it either sort of like deactivates itself, or some sort of warning is raised. There will also need to be, also I'm just moving the screen around, there needs to also need to be some way of sort of maintaining these devices. So you will have issues where these devices will malfunction, whether it's just wear and tear, or they just never worked in the first place, or you need to install some software, and you need to be able to physically access them as well. Because bear in mind, if you have an Internet of Things device that actually fails, it could actually create a hole in the security, and somebody could either compromise that, or it could create a hole in the protection which people can access through. They will also need some sort of power source. Again, sometimes they could be plugged into the main electricity, but depending where they are, if they're quite remote, as I mentioned in the earlier case before, the security camera, it needed its own battery. So again, you need to ensure that this battery is maintained, because again, if the Internet of Things device fails because of a flat battery, you don't know whether somebody's actually replaced it, or smashed it or something. Also, it could create a hole in your security, which you need to plug. And last but not least, without stating the complete obvious, the Internet device will also need some sort of hardware or connection to the Internet to work and pass data. Effectively, you look at it, is this a device? So that basically means you need some secure way of passing data that can't be, compromised by a man-in-the-middle attack, or any other thing, or somebody can compromise the encryption. So again, that needs a lot of checking, and you need to ensure that that is looked after. And again, sort of like I mentioned here, again, sort of like slightly repeat myself about this thing about customers, suppliers. You need to ensure that, if you're using suppliers for cloud providers, or you're using the supplier to host machine learning or big data calculations and processes, you need to ensure that you're happy with their physical access. You don't want people willy-nilly walking into data centers and everything just to have a look around. Again, for customers, I won't exact the same point. And last but not least, it's one of the things is around COVID-19, etc. Is that again, you just need to ensure that people who are using COVID have a remote access. Right, almost on the home run now. So application maintenance, again, this is like the software packages. Ensure they're kept up to date. This includes any network software, operating systems and applications. Again, work with your vendors and everything, and suppliers of these to ensure what is the most up-to-date packages. For certain areas, again, it may be challenging because you're using things such as Internet of Things devices, which you may have to physically get next to upgrade, but such is life. And the other thing just to be aware of is update conflicts. I've worked many, not so bad these days, but if you went back a few years, you would actually find certain applications wouldn't work with the latest operating systems, or the latest operating systems wouldn't work with out-of-date applications or virus checking packages, or there would be conflicts in sort of like firewall technologies. So just to make sure this is where it comes to having a very skilled staff to understand what works with what. Unapproved applications, ultimately, the bottom line is if an application is not approved by your organization, then it shouldn't be installed. First of all, that apart from the fact you could install a package that compromises internet connectivity. For example, if you have you could have a hole in it, or it could ultimately, it could even be a rogue application such as a virus. Therefore, you should ensure that you have restrictions in your infrastructure to stop this happening. And if people constantly try and do it, then I've seen places where people have actually been dismissed from their job. So this is quite an important one. Again, you want to make sure suppliers are doing the same. If you're using the supplier to provide a cloud or a set of internet thing connectivity, or running machine learning algorithms, you want to make sure that their applications are actually are correct as well, that they're running updates, they've got the latest versions of the packages, they're not allowing people to install applications willy-nilly and causing all sorts of havoc. And the same with customers. Again, it's the same point again I mentioned there. Next one relates to data access itself. Again, a lot of this is pretty standard stuff, but I will bring out the points that relate to the new technologies. Strong passwords. Passwords being strong has been a challenge since day one, but it's very important to use strong passwords and keep privileged accounts protected. Again, it's standard processes. This force passwords to be changed, use 2 or 3, and I've even seen some cases 4-tier infrastructure. Validations. Access to applications and data, again, standard practice, only give people access to the data they need to do their jobs. The concept of least privilege is actually quite a good use here. For example, basically that means is no one gets access to anything until they can prove they actually need access, and you work your way up. That's a good way of doing it. Cloud segregation. Again, when you outsource to the cloud and move data to the cloud, the idea of the cloud, it goes into one sort of like virtual bucket, and the data is spread around the globe to ensure that it's maximized reliability and scalability, which is very, very good, and it's a fantastic benefit. But the challenge is, though, you want to make sure that there's data between you and your other cloud provider users is segregated. The last thing you want to do is find other people's data on your shared drives or vice versa. So therefore, you want to make sure that the cloud providers you're using have got clear processes in place and ask them to demonstrate that they actually work. And the other is another area is around cloud data location. You know, exactly where is your data? Is it overseas? And are you happy with this? Obviously, one advantage of the cloud is you put something on and your data gets spread around the globe, and it creates a scalability, reliance, and minimize, the theory should minimize disruption. But that means actually you could have data spread around the globe. You know, you could have data. You know, I mean, I worked at a country in the UK. They were and had data in the cloud, put it in the US, UK, Australia, and New Zealand, and Japan. But if you're happy with that, that's not a problem, and that's good news. You can tick it in the box, but you've got to be very careful that you haven't got any client, supplier, or regulatory contracts in place. One of the examples you could actually have is that, excuse me, is that you may have a client. I remember I worked with a client once who's a UK organisation who said they didn't want any data outside the UK. So when as it happened, they weren't a cloud. It was before cloud computing happened. But if that was a problem, we had to say to the cloud provider, all our data's in the UK. Again, some suppliers, if you're using an application, a software application, you know, some suppliers might say, we don't want you to deploy the application outside the UK or the US or the Europe or Spain or wherever, because they're worried about the data or the software being stolen. And also there's certain regulatory and legal contracts in place as well. For example, having worked for the US, they are not worked in the US as the United States. There's lots of stricter rules about what data can be displayed outside the US, what data needs to stay in the US. And again, you've got to be very careful that your cloud provider doesn't accidentally put the data in an illegal country. Again, with suppliers, and this is, you can see these and customers, these 2 points will pop up everywhere. So these are the 2 key points to mention. Again, not only your own data access, you want to make sure suppliers and customers have got the same controls in place. Right, almost there now. Networking. Okay, cloud encryption. You need to ensure that the data on the cloud is encrypted to the levels that you're happy with. If you're happy to have completely unencrypted data, then so be it. I wouldn't recommend it. I would ensure there would be some cloud computing, some sort of encryption of the data, just in case A, it gets lost, or B, it gets the segregation is not perfect. Is that, you know, somebody can't actually go and steal your data, especially nowadays. Encryption is so powerful. Cloud communication. Again, a common theme is obviously when you communicate with the cloud. You know, you want to obviously almost give the impression it's on the PC next to you, but you want to make sure there's very, very tight encryption in place. So if a man in the middle attack happens or something like that, is that the person, even if they do steal the data, they can't unencrypt it, and it's next to them is useless. Internet of Things connectivity. The Internet of Things will require data to be passed from the various remote objectives. Therefore, again, you want to ensure that all data on the Internet of Things connectivity is encrypted. Again, if it gets hijacked, you're okay. And again, the last 2 items down here relate to suppliers and customers. Again, it's a common thing. Okay, so we've just done the main hints and tips. I can see I've got one text message here. I'm just going to open it up. Right, please provide an example of practical clouds. I'll come to that. I'll do those questions at the end. Is it Monsieur? That's great. And this moving down is to the final item there is AI technologies are used to help cybercrime. So most of this has been around the problems with AI technology and how that can actually help, or sorry, it can actually cause cybercrime and cybersecurity challenges. But I think what we're finding now is a lot of the new technologies are being implemented to a lot of new AI technologies have been implemented to help combat cybercrime, especially these days with concepts of big data and machine learning, where you can, big data, you can obscene amount of data of people's behaviors and technology behaviors and networking patterns. And it allows algorithms to be created to monitor threats and detections. And this actually then will allow, once you understand the other common themes, certain threats like man in the middle or denial of service attacks have got common themes and patterns. It will then allow firms to predict what's likely to happen or what's not likely to happen. And therefore you can predict gaps and problems and suggest improvements. So this is where AI actually helps with cybersecurity as opposed to becoming a risk, which is actually quite a nice way of doing it. Okay, so I think we've covered all the areas now. So we've got we've done a few key definitions. We've gone through technology in the world is getting linked together. We've talked about what cybercrime and cybersecurity is. We discussed the threats. We've discussed a number of hints and tips on how to get around them. Again, it's not an exhaustive list. And we've also talked about how AI technologies, in particular machine learning techniques, can be used to help combat cybercrime. So first of all, thanks for listening. And therefore, brings us to the very last thing there is that if you need any device or would like to discuss anything on this, or general feedback, are always welcomed. Therefore, you've got my email address there, which is a Google Mail account. I've got my Twitter handle if you want to post a message there, or LinkedIn connection, which is at the very bottom there. But I'm normally best to respond to email, to be honest with you. Twitter, I don't tend to use very much. So just a few questions come up there. I think the first question was, will this recording be shared? I assume so. I mean, I don't actually work for iExperts. I don't know if anyone on the iExperts team can actually answer that.
So since you mentioned this email, I didn't want to say anything, Paul. It's a very exhaustive and amazing cover that you have done in the entire spectrum of cybersecurity. My name is Hassan. Yeah. I work at Nebesky Labs and as institutionally funded startup working in IoT. Now, one of the key question is we are working with hardwares, physical layers. Yeah. Now, with respect to, I will anyway write about it. Or should?
Well, I can't quite hear the question. Actually, I don't know if it's my dodgy mic or you're fading in and out, but yeah, I can see it now. Hi.
Hi. See, with respect to, we are an IoT company and a startup, and we are working on, we are basically working on connecting meters, the physical elements into the system. We are a middleware between IT and OT. Yeah. And since we are a middleware, so we have to deal with a variety of, different sorts of equipments. On the physical layer level, what kind of, I mean, is there any security standards or a framework that we could follow? I mean, on the physical level, I'm not worried about the, we are far ahead with respect to IT. This is very clear. Not
there is. I mean, what I could probably do is, off the top of my head, there are various, in the UK, they call them ISO, International Standards Organization. There's various standards. Let me, I don't know if you want to email me your email address and I can dig out some details offline and send them over. I mean, because off the top of my head, I can't remember. But the rule of thumb is when we use, going back many years, I can tell you a few years younger than me, is that when the very first time people will put servers in their DMZ, going back, what they used to do is on the hardware side and the software side is to minimize, literally uninstall as much as they can from those servers. So if those servers got compromised, there wasn't much they could do anyway. Because in those days it was mainly FTP type stuff. So the rule of thumb is have as little as you can on the physical hardware than you can actually have, because if it does get compromised, there's not much one can do, But if you send me the details, I can dig out some frameworks.
But on the physical level, we have increased one layer, which is the edge computer. So, I mean, anything that comes first, we have that layer, security, with a separate operating system running. Anyway. Okay. I will write to you. Thank you so much, Paul. It's a very nice presentation, very useful, and
No, that's fine.
I would like to be, share it in my LinkedIn for the people that I know. Thank you so much.
That's great. Okay, that's great. Just got a few other questions coming down here. So I'm just reading. I'm going to take them from the bottom because that's the way it's scrolled out, unfortunately. There's one question. What do you, as in I, think about using blockchain to secure Internet of Things devices? Yeah, I think that's a good idea, actually. I think the encryption on blockchain is actually quite good. Well, it's not good. It's very, very good. Yeah, I think that's fine. I have no problems trying to use the concept of blockchain to secure Internet of Things devices. I think the only issue I've always had with blockchain is, again, it's probably slightly out of date, is that blockchain can be perceived to be quite slow to run. So it could actually be a perception issue with your clients that you need to manage. And the other one was, I'm just rolling up here actually, apologies with everyone. And there's another one from, I think it's Monsieur, apologies if I pronounce your name wrong. It says, please provide example of practical cloud segregation. Well, it really comes down to what you want to pay for, to be honest with you. When you work with one, you can have a very simple, I mean, again, I can provide some information offline on this. It's at one level, if you take the cheapest cloud model, you're merged in with everybody else's data, and there's and you're very much reliant on your own sort of security to the cloud provider to stop segregation. And why I mentioned it a few times, on the whole, I've never heard it happen of any significant source. The best way to highlight or segregate data is actually do a private cloud, which is basically you have to pay more money. But actually ensures that you've got your own mini cloud, if you want, within the major cloud. Okay. Okay, I've got a few people say, can I share the screen again? Bear with. Sorry, unfortunately, I'm on a very small laptop here at the moment.
Sorry.
Okay, that's fine. Okay, that's good. So I think I've answered all the questions anyway. I'm just going back again. So bear with. Right, has anybody else got any other questions they'd like to ask at all? Right, I think Noran's just mentioned to everybody the recording will be shared. And what Noran I can do is after this, I can email you a copy of the slides if people want to copy the slides sometimes. Obviously, see, sometimes it's a reasonably long talk, this, isn't it? And you might want to dive to a little bit yourself. Right, is there anything else from anybody else at all? No? Okay, I suggest that we bring it to a close. So thank you for your time. Thank you for bearing me for the last an hour and a bit. Have a good day, and obviously you've got my details there. If you need to contact me, feel to contact me. Otherwise, hopefully speak to you soon, guys.
Thank you, Paul.
Bye-bye. All the best.
Bye.
Bye. Thank you.